So welcome back to the course on climate change. In this lesson, we're going to be talking about the cryosphere. And the cryosphere is basically everything that's frozen on planet Earth, and particularly at the surface of planet Earth. And for the occasion, I've also put on a sweater today, since it's going to be cold in this class. Well, the cryosphere, if we start in the polar regions, we have sea ice. We have ice which is covering the oceans. We have ice covering the land. The main two ice sheets we have are in Greenland and in Antarctica. We have snow on the mountains, glaciers in the mountains, and we also have frozen ground, areas we call permafrost, where the ground is below 0 degrees throughout the year, including the summer. And so the water in the ground is also in the form of ice. So all of these areas of the planet which are frozen throughout the year, perennially throughout the year, we call the cryosphere. Now, how do we get ice and ice sheets and on Earth? Obviously, this all starts as snow. And so we've spoken about clouds and how we produce rainfall. When the temperatures in the atmosphere are below 0, we also have ice crystals and snow formation. When snow falls to the ground, we know that it's very light and fluffy, and it has a very low density of about 0.4 grams per cubic meter, compared with ice, which is more than twice that, about 0.9 grams per cubic meter. But it takes time for snow to form ice, and this can take quite a long period of time. What happens when the snow falls is that it eventually builds up a thick layer of snow, and the weight of the snow starts to compact into an intermediate phase we call firn. Firn is between snow and ice and has a density which is less than about 0.85 grams per cubic meter. As the snow also starts to evaporate or starts to melt at the corners of the dendrites that you can see in the image when it falls down, when it gets warmer in the day or between summer and winter, it becomes more and more spherical, which can also compact the snow into a denser form and giving us also higher density. Also, when we have melting of some of the snow and refreezing during the night or during the winter, we can produce ice. But in very cold regions, like Antarctica and in Greenland, we can actually build up maybe 150 meters of snow before we have enough weight and mass to compact the snow into ice. And so this can take a very long period of tens of years and sometimes hundreds of years, depending on the temperature in that location. So let's split the different types of ice bodies into the sea ice, into land ice, and also the permafrost. So let's first talk about sea ice. First of all, we've already spoken about the significant difference between the North Pole and the South Pole of the Earth. The North Pole doesn't have any land, it's only oceans, but covered in ice. We can see here on the left, looking down on the North Pole, we can see the sea ice shown in white in the winter on the left for 2016 and in March 2016. And next to it, we can see the distribution of sea ice at the end of the summer in September of the same year. So the sea ice grows in the winter, it spreads out, covers the ocean in the North Pole and around Canada, in Russia, melts in the summer, but we've always got sea ice covering the North Pole throughout the year. If we look at the South Pole on the right-hand side, Antarctica is solid rock and mountain ranges there covered in ice, but around the continent of Antarctica, again in white, we can see the extent of the sea ice, which forms every winter. Here we see for 2015 in October, the distribution and the extent of the sea ice. And then we can see what happens also in the summer, in February of 2016, where we have much less sea ice. We still do have sea covering the oceans, but much less, obviously, than in the winter. When we look at the area covered by sea ice on a global scale, it's about 25 million square kilometers. That's about the size of the whole of North America, so it's quite a large area. And compared with the land ice, which is basically over Greenland and Antarctica, there we only have about 15 million square kilometers, which is about roughly 10% of the Earth's surface. So we have a lot more ice covering the oceans than we'd have covering the land. When we look at the land ice, the two main ice sheets we have today are over Antarctica. So we spoke about the ice over the oceans, but the whole of Antarctica, most of Antarctica is covered in ice, an ice sheet, which can get up to 4 kilometers thick of ice over the South Pole. And on the right, we can see that in the Northern Hemisphere, the only big ice sheet we have is over Greenland. Greenland is also a few kilometers of thickness of ice we have covering Greenland, and we can see that also relative to the sea ice we have over the North Pole. And then the last type of frozen ground that we have as part of the cryosphere is what we call permafrost, because it's permanently frozen. And the different colored shading here shows you the regions where the temperatures are below zero throughout the year, and therefore the ground is solid. Even though it's not covered necessarily with ice or snow, the ground is solid, frozen, because it's so cold. And the different shadings here show you the percentage of those regions which are covered in frozen grounds. And it's also divided in the more greens are in the low-lying regions, and the purples and the oranges are more in the alpine mountainous regions. So we can see even places like Tibet, which are very high altitude, there's a fair amount of permafrost. Obviously, as we go closer to the polar regions, we see more and more permafrost because the temperatures get colder and colder.